Today we are going to learn about the Pythagorean theorem and its converse. More specifically, we're going to identify triangles by using the Pythagoras' theorem and note that they are right triangles because of the converse. The Pythagorean theorem says that if we have a right triangle, this is not drawn to scale, then the side squared plus the other leg squared must be equal to c squared. If we have a right triangle, in order to know that it's a right triangle, then a squared plus b squared plus c squared must be equal to a squared plus b squared must be equal to c squared. That's the length squared of one leg plus the length of the other leg must be equal to the hypotenuse squared. In this lesson, we're going to use the converse that shows that any triangle where the three sides are equal to the Pythagoras' theorem, then we know for sure that it is a right triangle. We're going to do an example. In this example, it says use the length 5, 12, and 13 centimeter as the sides of the triangle below and determine if the triangle is a right triangle. So, first we're going to label the triangle with the sides. We know 5 is one leg, and then the other leg would be 12. And then the third leg, because that's the longest of all three, that would have been 13 centimeters. Now to determine, we're going to use the converse of the Pythagorean theorem to prove that this is or is not a right triangle. So first let's just write the Pythagorean theorem. A squared plus b squared plus c squared. A squared plus b squared is equal to c squared. We're going to plug the numbers in, so 5 squared plus 12 squared is equal to c squared should be 13, so it should be equal to 13 squared. Putting those numbers in the calculator, this is 25 plus 144 is equal to 13 squared is 169. So let's just add these two and we will get 169 is equal to 169. So yes, this is a Pythagorean theorem. This is a right angled triangle. Because 169 is equal to 169, then it is a right triangle. Let's try another example. A blueprint for a new triangular playground shows that the sides measure 480 feet, 140 feet, and 50 feet. It's the playground in the shape of a right triangle. We need to put the sides in. The smallest sides, 150, then 480, and the longest side, always the longest side, the hypotenuse will be 500 feet. Okay, so as usual, we'll start with the Pythagorean theorem. A squared plus b squared is equal to c squared. Let's plug those numbers in. 140 squared plus 480 squared is equal to 500 squared. 140 squared, if we put that in the calculator, that should be 19600 plus 230400, and that should be equal to 25. 5 times 5, 25, 100, 100. Okay, let's add these two together. And then we will get 0, 0, 6 and 4, 10, 9 and 1, 10, 3 and 1, 4 and 1, 5, 2, 250,000 is equal to 250,000. Therefore, this is also a right triangle. Okay? So here we have it. Square them both. Then once they become equal, then that will also be a right triangle. Okay, we will look at another example. The question asks, can the lengths 10 centimeter, 8 centimeter, and 9 centimeter form a right triangle? The only way we will know that is if we can confirm whether the three sides will be a right triangle. So let's try them again. Our smallest sides, a squared plus b squared is equal to c squared once more. No, a squared we're using for 8 squared plus 9 squared is equal to 10 squared. 8 squared is 64 plus 9 squared is 81 plus 10 squared is 100. That should be an equal sign. Let's just go ahead and add these two. 4 plus 1, 5. 8 and 6, 14, 145. Is that equal to 100? No, that's not equal to 100. So this is not a right triangle. Once we use the converse of the Pythagorean theorem, it will help us to decide whether we have a right triangle or not. I hope this video helps you to understand the Pythagorean theorem, the converse of the Pythagorean theorem.